Welcome back. Today, we've got a fascinating explainer that's diving into some freshly released industry data. And honestly, it kind of challenges everything we thought we knew about industrial testing equipment. We're looking at a classic David versus Goliath story here. But, instead of slingshots, we're talking about precision emissions testing, specifically selective catalytic reduction, or SCR performance testers. So let's just kick things off with a fundamental question. Does extreme accuracy always require extreme budgets? Because, well, in the automotive sector, the assumption has pretty much always been that if you want institutional-grade data, like the kind of data you can literally stake your regulatory compliance on, you absolutely have to spend institutional-grade money. But what if the data is telling us a totally different story? What if we could actually get world-class precision without that massive overhead? Okay, here's our roadmap for this explainer. First, the SCR testing challenge. Second, Donga's innovative tester. Third, the accuracy head-to-head. Fourth, the exceptional error margin. And finally, real-world cost efficiency. Let's get right into it. Section 1. The SCR testing challenge, meeting Euro 6 standards. Right, so under strict Euro 6 emission standards, heavy-duty vehicles are facing a really relentless cap. Nitrogen oxide, or NOx, emissions are strictly limited. According to the source data we're reviewing, if an inspection shows a vehicle's emissions exceeding 900 parts per million, boom, it is an immediate fail. There is literally zero wiggle room here. If your SCR, or your diesel particulate filter, your DPF, isn't performing at its peak, you're off the road, period. Now, for years, the absolute gold standard for measuring this, the Goliath in our story today, has been the traditional engine dynamometer. We're talking about massive, sprawling machines like those used by KTEC, the Korea Automotive Technology Institute. And look, these huge installations, they are incredibly accurate. They're the undisputed industry standard. But they're massively expensive, they take up a ton of space, and for a standard fleet operator, they're just incredibly difficult to access for day-to-day testing. Which brings us to Section 2, Donga's innovative tester, the accessible challenger. Take a look at this. This is Dong ENC's heavy-duty SCR performance tester. As you can see, it's a completely localized, self-contained unit. It's actually designed to fit right into a standard industrial workspace or maintenance shop. You don't need a multi-million-dollar testing facility just to turn it on. It holds the heavy-duty SCR unit securely on this specialized rig, making it a super accessible alternative for real-world, everyday application. But I know what you're thinking. Looking the part and actually acting the part are two very different things. And you'd be right. The hardware is really only half the story. The software and the sensor array are what actually capture the data. You've got this sophisticated digital interface built directly into the Donga unit, and it's generating real-time NOx measurement curves. It tracks temperatures across multiple points, so the DOC rear, SCR front, SCR rear, and most importantly, it's continuously tracking the NOx levels entering and exiting the system. It treats the data just as seriously as the massive dynamometers do. Honestly, those giant multi-million-dollar setups might be sweating a little bit looking at this. Moving on to Section 3, accuracy head-to-head. Donga versus KTEC. So we have the direct comparative test results right here, and we're going to methodically break this data down. The test looked at 3 completely different scenarios to make sure the equipment didn't just work under perfect conditions, but across the entire life cycle of a part. They tested a brand new SCR, a remanufactured SCR, and an old, heavily used SCR. They ran these units through the Goliath, the KTEC engine dynamometer, and then ran the exact same tests on our David, the Donga ENC tester. And the crucial point is right here in these specific error metrics. Listen to this. When testing a brand new SCR, the KTEC dyno measured a 98.0% efficiency. The Donga tester, it measured 99.2%. That's a mere plus 1.2% error. For the remanufactured SCR, KTEC read 97.8%, and Donga read 98.2%, a microscopic plus 0.4% error. And honestly, perhaps the most impressive one. For the old SCR, KTEC measured 84.1% efficiency, and Donga tracked it practically perfectly down to 83.3%, which is just a minus 0.8% error. All of which leads us perfectly into Section 4, the exceptional error margin, world-class capability. If you take nothing else away from this explainer, this is the number you need to remember, 1.5%. Across the board, whether the part was brand new, rebuilt, or practically at the end of its life, the absolute maximum error margin between the massive, insanely expensive KTEC engine dynamometer and Donga's accessible localized tester was within a remarkably low 1.5%. And this really brilliantly illustrates why that 1.5% matters so much. Look at these continuous tracking curves. You've got the red line showing the high NOx input and the green line showing the reduced NOx output. The Donglaw equipment isn't just making a lucky one-off guess here. It is continuously tracking that incredibly complex chemical reduction process with true institutional-grade capability. I mean, this exceptionally low error margin proves beyond a shadow of a doubt that Donglaw's equipment possesses world-class precision. Let's wrap it up with Section 5, Real-World Cost Efficiency, Precision Meets Profitability. Because here is the real-world impact. Without accurate testing, fleet managers are basically operating in the dark. If an emissions light pops on or a truck fails an inspection, the traditional knee-jerk reaction is just replacement. And replacing these heavy-duty emission systems is painfully expensive. We are talking massive capital expenditures, historically up to 3.3 million won in some traditional replacement scenarios, simply to swap out parts because operators couldn't precisely verify if a good cleaning would actually solve the problem. Let's put the incredible scale of these savings into perspective using the source data. When you have this Donga tester in your shop, you can confirm with 98.5% accuracy that a professional cleaning has successfully dropped those NOx levels down to a perfectly safe 100 to 200 ppm. That's well below that 900 ppm legal limit we talked about. The data shows that blindly replacing 100 new DPF or SCR units would cost a fleet roughly 130 million won. But if you can precisely test and validate those units, cleaning those exact same 100 units costs only about 8.5 million won. That is an astronomical difference. Testing validation is literally saving fleets hundreds of millions of won. Which leaves us with this final thought. The data here is pretty unambiguous. The Goliath of testing is no longer the only game in town. With Dongyi ENC achieving institutional-grade precision that is verified accessible within a 1.5% margin, isn't it time to rethink your emissions maintenance strategy? Why keep paying for guesswork or massive unnecessary replacements when true precision is now right at your fingertips? Thanks for joining me on this explainer. I really hope this breakdown helps you make smarter, more data-driven decisions out there.